Alright, this one's kind of like the parallelogram method, since it's tail to tail. And start from where they're together and complete the diagonal. This next one is already tip to tail, so just complete it from start to end. And this one is kind of like +1 and -1. I don't know what to do with that, but put a dot. This one, we need 2a and half an a. I'll come down here and do, we have to do a minus b, so I already have a. I will minus b over there, and I should have put a minus b there. Alright, a minus b again. Minus b is going to be this way. Might have made that one a little too long, but there's my answer. And minus b is going to be here. And then my whole vector will be the whole one there. Now let's do 2a. Oh, I probably shouldn't have drawn that there. I didn't think ahead. Let me start over here. Sorry about that. 2a and minus 3b. So 1, 2, 3, minus 3b. And let's continue that. Woo woo. Alright, they want to know the x's and y's. There's my x. And there's my y. Here's my y on that one. There is no y over there. Here's my x, and this one's all x. So now we have to find that x and that y. I am going to go 180 minus 130 and get a 50-degree angle there. And so let's do the red one first, and that's adjacent, so that's cosine of 50 degrees equals x over 5. So 5 times the cosine of 50 equals x. And if you put that in your calculator, you should get 3.21. Blue is going to be 5 times the sine of 50 equals y. And you put that in your calculator, you should get about 3.83. Let's do the red here and the blue. Remember, it's going to be 4 times the cosine of 30, and that's going to equal negative 3.46. And then this is going to be 4, whoops, wrong color. A little weird about the color. Doesn't make me a bad guy. 4 times the sine of 30 equals, this is going to be negative as well, isn't it? Negative 2.00. And I think you see a pattern developing. I need that x, and I need this y. So it's going to be 5 times the whoops, wrong color again. It's going to be 5 times the cosine of 45, and that should give us about 3.54. And 5 times the sine of 45, you know anything about triangles, you know it should be the same number, and I did not do it in blue, but they're both the same. Now what they want you to do is add up all, I should really do that over, shouldn't I? Five times the sine of 45 equals negative 3.54. So what I want to do is I want to add up all of these for this right here. And when you do that, you should get negative 3.13, and then add up all the blues. And this should give you negative 1.71. Can a vector have a component equal to 0 and still have a non-zero magnitude? Yes. As long as one component is non-zero, that makes the entire vector non-zero. This would be no. Kind of the same thing as the last one. As long as one component is non-zero, the vector will be non-zero. Woo-woo? Woo-woo. Alright, let's go up here. My x is 3. My y is negative 2. And you would do the parallelogram thing on here. And you would get a vector like that. And the vector is going to be 3 squared plus 2 squared equals 3.61. This would be negative 2, but once I square it, I should get 3.61, right? Square that, you get a positive number. And the angle would be inverse tan of 2/3, which gives me an angle of 33, negative 33.7 degrees. Let's do the next one. My x is negative 2. My y is 2. That's my vector. And this is going to be we were supposed to square root this over here. Sorry about that. It's going to be the square root of 2 squared plus a negative 2, but the whole thing gets squared. And this is going to give me 2.83. And the inverse tan of 2/3 gives me, whoops, not 2/3. Inverse tan of 2/2 gives me a 45-degree angle. That just kind of makes sense, doesn't it? Alright, let's keep moving here. We have x of 0 and a y of negative 2. C equals 0 squared plus 2 squared. Square root answer, you're going to get 2. And my angle is a negative 90 degrees. Alright, the x is going to be 5 times the cosine of 30, which is going to give you 4.33. the y is going to be 5 times the sine of 30, which gives you 2.50. Over here, they're messing with our axis. We saw that before. Here's our y. Whoops, I just crossed out y. There's our y. There's our x. So this would really be a 60-degree angle. So I'm going to go to the proper color. X would be 5 times the cosine of 60. And that's going to give me 2.50. And my y would be 5 times the sine of 60. And that's going to be 4.33. This one's really weird in that my x is there and my y is there. So this little angle here, you gotta kind of be a geometry whiz. This whole angle here is 45. So 30 minus 45 is 15. This angle here is a 15-degree angle. So I have to find my x, which is going to be 5 times the cosine of 15. That's going to be 4.83. And my y is going to be 5 times the sine of 15. And that's going to give me a negative 1.29 degree angle. This next one, it says draw vector arrows of the ball's acceleration at the dots. Well, you're going to have a big acceleration there. You're going to have 0 acceleration there because it's horizontal and gravity doesn't do anything. I'm going to have a small acceleration there because it's a small incline. I have 0 here, and over here my acceleration is going to be a little bigger than this second one, maybe not quite as big as the first one, and that's all there is to that one. Woo woo. This one's kind of fun. It says you go from 0 to 1 to 2. So what they're saying is this is my V initial and that is my V final, and then they want us to add them to find acceleration because VF minus VI divided by some sort of T. Yes, I made that line a little too long. So let's do the math on VF minus VI. Wouldn't I draw VI like this and label that negative VI, and then my change would be right there. That was fun, wasn't it? This one is just the same thing. You go up. We did this one in class, sort of. And then you go over. So this is VI. This is VF. If I were to subtract VF, I would come down like that. And my new vector would be from the start to the finish. And the last one. Same thing. Let's get a color here. Here's my VI. Here's my VF. VF minus VI, since it's going that way, I'm going to have to switch around and go that way, and my new vector is going to come down. And the last one, we go from here, VI, here, VF. I'm kind of lazy. I'm going to do minus VI here. I haven't been labeling these, have I? This was minus VI. VF minus VI. And I'm going to finish this bad boy up from beginning to end. Woo woo, woo woo.